Right, we are solving 889 construct binary tree from preorder and postorder traversal. So basically we have been given preorder and postorder traversal and we have to construct the entire tree. And this one is similar to the one problem where you have to construct using in order and I think preorder. But yeah, the logic behind this is it's a bit difficult. So um, so pre pre-order goes like you visit, then you go to the left, and then you go to the right, right? So pre-order is visit left right, and post-order is left right visit. So um, in the similar way like we did in that problem, you have to kind of make use of the indices to figure out the size of the left subtree and the right subtree. So, for example, uh, you know the first node is gonna be the root in pre-order, but you don't really know if the next node is gonna be the left subtree or right subtree. That is why they have mentioned that there might be multiple answers, right? So to figure that out, you can always assume that the second one is going to be the left one, and then if you have more you can add it to the right subtree, right? So uh, so let's say you take the second one, right? So how would you figure out what are the like what elements are in that subtree, right? So for value 2 you need to find the index in the post order reversal. So that's gonna be 0, 1, 2, right? It's the second index, right? So post order means that you've already visited all the elements to the left and the right of 2, like before that. So that means this entire thing is gonna be the left subtree, like the subtree comprising of 2 as its root. And in the similar way, you can find the right portion as well. So if this is the left and we know that last one is going to be the root, then the remaining one must be the right portion, right? So in the similar fashion you have to figure it out, and then like the problem you have to recur on the left and the right subtree. So uh, the code might help with the explanation. So first of all, we have to get the indices. So let's define an indices array, and for I comma v in enumerate post order. So indices of value is gonna be equal to the index, right? So now we recur. So the the portion where we select the left and the right window, we're gonna denote the ends of the window by like 4 pointers. So it's going to be I1, I2. So I1, I2 for the pre-order, and initially I1 is going to be the 0 and I2 is going to be length of pre-order -1. Similarly, G1, G2 for the post-order, and it's going to be 0 and length of post-order -1. So we have def recur I1, I2, G1, G2, and we are gonna return the roots. So we can just call recur here and just pass I1, I2, G1, G2 here. So in this recursive function, the base case would be if I1 is greater than I2 or if J1 is greater than J2, right? So the window is invalid. In that case, you just return none. Now you can first create a normal tree node, right? So let's say it is current, and current is equal to tree node. So current is gonna have the value preorder uh, I1, right? And let index be the next index. So index is essentially gonna be uh, preorder of I plus one. So indices of preorder of I plus one, but we need to make sure that sorry, I1 plus one. We need to make sure that I1 is valid. So a common, like a general way would be if I1 is not equal to I2, then we're gonna do the following, right? I1 not equal to I2 means that there's essentially, like, if I1 is equal to I2, there is essentially just like one element in our tree, in our like window, and that is current element. We can also write current dot, for now we can write current dot left is none and current dot right is equal to none, or maybe like just left and right, we can declare left and right, and then like before we are gonna return the current root, and before returning that we're gonna assign left to its left node and right to its right. So yeah, so in this if statement, we got the index here from the next element. Now we have to check if it's, like, we have to figure out its sizes. So let's say we have size left as the size of the left window. So in this case, this one, this window, or like this window, right? So size left is gonna be index minus g1 plus 1, uh, and size right similarly is gonna be I2 minus I1 plus size left. So you can play around with this to figure out how I got this, but these are kind of pretty simple because, so index is, in this example, index is 2 and g1 is 0, so 2 plus 0 plus 1 is 3, so that's the size left. After you get size left and size right, so you just check if size left is greater than 0, you're gonna have left is equal to left recur. Now we're gonna recur on I1 plus 1, so the next element we're gonna recur till I1 plus size left, uh, and sorry, G1 is gonna be the same, and G2 is gonna be G1 plus size left minus 1. So the new window bounds. Similarly, if size right is greater than 0, we're gonna have right is equal to recur on I1 plus size left plus 1, and I2 is gonna be the same, I2. uh, G1 is gonna be G1 plus size left, and G2 is gonna be G1 plus size left plus size right minus 1. That seems alright, and yeah, we assign left and right, and then we just like recur. So let's try submit it. Okay, there you go. Let's give it a submit. Alright. uh, I would say pretty difficult from the last problem, which was actually a Leetcode hard, and this is a Leetcode medium. So, but a good problem nevertheless. All right, see you tomorrow.